Hello everyone, you are welcome back to our tutorials on intro analysis. Today we are going to pick some random questions and then try to look at them. So we are looking at some random questions. So the first one is on limits, where we have to apply the L'Hopital's rule. As usual, we've done something like this before. So um, let's say we have the limit as n approaches infinity of tan x power sine x, like this. So as usual, what do? We just do some small transformation by saying that, okay, so we are going to let tan x power sine x equals to y, where we will take log of both sides. So by taking log of both sides, we have this equals to log y, and with this we have sine x ln of tan x equals to ln y, like this. Now we then take base e of both sides, so this will imply that we have the y equals to e power sine x ln tan x, like this. And so our limit, we can then write it as limit as n goes to, sorry, this is I think this is supposed to be x, not n. This is supposed to be x, sorry. As x goes to 0, not infinity, as x goes to 0. Yeah. So this is how the question is supposed to be. Supposed to be 0 here, and here is supposed to be x, not n. So kindly take note. So as x goes to 0 of e power sine x ln tan x, like this. But you know that we can write this as e, the limit as x goes to 0 of ln tan x all over 1 over sine x, like this. Okay. So the limit of this one, like this, e power that. Okay, so right now, which we can write as e power okay, so taking the limit as x goes to 0, that will just mean that we have ln of tan of 0 over 1 over sine 0. Okay, so you know that tan 0 tan 0 is 0, and so ln of tan 0 is infinity. Okay, so that will just be e power infinity over 1 over sine 0 is also infinity, and so you have this, which is undefined or indeterminate. So what do? We have to apply the L'Hopital's rule. By that, we are differentiating the top and down. So we have the limit e power, the limit as x goes to 0, d dx of ln of tan x all over d dx of the 1 over sine x. 1 over sine x is equals to cosec x. So I'm going to replace that here. So cosec x, like this. And so when we do this differentiation, we have e power, the limit as x goes to 0 of 1 over tan x times sec squared x. That's the differential of this. So we differentiate it. That's a logarithm function. So all over the differential of cosec is negative cosec x cot x, like this. So we do our manipulations, and so if I manipulate this part, that would 1 over tan x is the same as cot x, and cot x is cos x over sine x times sec squared is 1 over cos square x, 1 over cos squared x. Now this one divided by cosec here is negative 1 over sine x. Cot x here is cos x over sine x, like this. And so this one will cancel one of this. You have 1 over sine x cos x divided by here we have negative cos x over sine squared x, and so we have 1 over sine x cos x times negative sine squared x all over cos x, and so this one will cancel one of this, and so this will imply that we have negative sine x over cos squared x, and so we can then write it as e power the limit as x goes to 0 of negative sine x all over cos squared x. And so we take the limit again. Now taking the limit, that will just be e power negative sine of 0 all over cos 0 squared, and so we have e power 0 over 1, that's e power 0, and that's equals to 1 as our final answer. Thank you for watching. Kindly subscribe.